In this video, we're going to take a look at graphing piecewise functions, and then at the end, we'll go ahead and do some evaluating. If you didn't watch the first video on the intro to piecewise functions, you should definitely watch that first, because that goes into detail of how you can graph each piece of the piecewise function. So let's jump right in and graph this first one. So we start with f of x equals 5. That's like y equals 5. That's going to be a horizontal line at positive 5. But it doesn't go forever. It only occurs when x is less than or equal to negative 4. So actually, let's go through and take a look at our range for each part of this piecewise function. So the first one happens when x is less than or equal to negative 4. So negative 4 is right there. So we're thinking everything to the left of this line will be the first part. The next part would be in between this negative 4 and go to positive 2. And then the last part will be graphed when x is greater than or equal to this positive 2. So those are our three sections. Now let's take a look at what each part will look like. So we start with a horizontal line at positive 5. And since it says x is greater than or equal to, there's going to be a solid point. So if we go up 5, we have a positive point right there, and this line goes to the left forever, so we put a line on the end. The next part is at positive 3, and at negative 4, there's a less than sign. And at the negative 2, it's a less than sign. There's no or equal to, so that means that we will have an open point here and an open point there. So we are at positive 3 for the f of x or y value. So we start there. We go all the way until we get to positive 2 and have a horizontal line between those two. The last part of the graph is a horizontal line at positive 1. And notice this time we have or equal to. So that means when we graph this one, it's going to be a solid point. So we're going to put a solid point at positive 1. I'm looking at the y value. And we start from positive 2, and everything greater than or equal to positive 2 goes to the right. We can go ahead and put our arrow on the end to show that it goes forever. And that's our graph. I think it's fine leaving like that, but I guess if I really want to clean it up, I can get rid of all this guide marks I had. So there you go, a nice clean graph of this piecewise function. Let's take a look at another one. This one is not going to have horizontal lines. If you're feeling confident, go ahead and pause the video and give it a try, and then you can hit play to see how it works. So I'm going to start by taking a look at the range again for each part. The first range goes from negative 1 to positive 5. So it's in between that line at negative 1 and goes until we get to positive 5. So our first line will be in between those two lines. And then the second line will just be greater than that positive 5 line. All right, next up, let's take a look at our first line, 2x minus 3. This is given in y equals mx plus b form. So I'm going to start with my y-intercept at negative 3, and then my slope of 2, or 2 over 1, is up 2, right 1, up 2, right 1, and I can keep going, and I'm getting closer to this orange line. And now I need to check, when I get to positive 5, what kind of point do I have? If you look over here, because of this less than, it's going to actually be an open point at the end of this line. Now, to get to the start of this, at x equals negative 1, I would go down 2 and left 1 from my y-intercept, but notice that one's going to be, that's going to be a solid point because it's less than or equal to. So I can put a solid point back here, and then I just do my best to connect these points, and that is the first part of this piecewise function. All right, next up, this line is given in point slope form. So I'm looking at this and I'm thinking opposite, don't change it. Looking at the parentheses, and the opposite of that -5 is a +5, and don't change the +7. And then notice when I do start this point at +5, it's going to be a closed point. And where is 5, 7? 5, 7 is the end of the first function. This often happens. Often, two functions will connect. And when they connect, they can't both be solutions. One of them needs to be a solution and the other one can't be. So this open point that you see, I'm going to actually fill it in for our second line. Yeah, we're definitely exaggerating these points here, aren't we? Now I do my slope of -1/2, so down 1, right 2, down 1, right 2, and this one goes forever to the right, so I just draw the arrow, and there's my complete piecewise function. I think it looks fine there, but I guess if I really want to clean it up, I can get rid of these orange lines, and there is your piecewise function. This last graph of a piecewise function that we'll do will combine what happened in the last two graphs. So go ahead and pause it, give it a try, and then check your answer. All right, so I'm going to start by figuring out when do these three separate pieces happen? What are the x values for each one? So the first one goes from -7 to -1. So in between those two lines is my first one. The second one goes from -1 to +3. And the last section goes from +3 to +6. So now I know when each section will occur. So let's start with the first one. It's given in point slope form. So I'm thinking opposite, don't change it. The opposite of the +7 inside the parentheses is a -7. And then I have a +1. When I start this graph, it will have an open point. And when I end it, it'll have an open point. So let's go to -7, +1, and put our open point. And now we're going to do our slope of 2/3 up to right 3. And when I do this a second time, I end up at the end of this section where I put a closed point. All right, next one is a horizontal line at +5, which will match up with our last open point. So now it'll become a closed point, and then we'll do a closed point on the end. So this open point at the end of our first section is now going to be closed, and we have a horizontal line at +5 that goes until we reach an x value of +3. All right, last one. We have a starting point of +3, +5, because again, opposite, don't change it. And we're going to have an open point at the start and a closed point at the end. So we start at, just like before, oh, you know what? Looking back, I forgot to connect my first part. Go ahead and connect it. There, that looks better. All right, so notice the point 3,5 is where the middle section stopped with a closed point. That's why it's technically an open point for the last part, because you can't have an x value that is used for more than one of the pieces of a piecewise function. All right, so the slope here is -4. So down 4, right 1, down 4, right 1. And when I do this one more time, I'm at my stopping point with a closed point right there. And then we will go ahead and connect these. Okay, not the straightest line in the world, but it works. There's our piecewise function. I'll just leave the orange lines there for now. I think it's fine if you leave them there. Normally, I guess if you want a nice clean looking graph, you could erase them. All right, so there we go. Now, the next thing we're going to look at is how do we evaluate points in a piecewise function? So we've added some points here that we want evaluated. So the first one we want to figure out is f of 4. We'll realize when we have a graph already drawn for us, we can just go to where is the x value of 4 and what point do we have? And that point is right here. that is where the graph crosses at an x value of 4, and its y value, or f of x value, is 1. So f of 4 is 1. Next up, we have f of negative 4. So if I go to where the x value is negative 4, this is where the graph crosses. So f of negative 4 is 3, and f of 2 would be right there, a value of 5. Now, that worked great when we already had the graph. But in our next problem, we're not going to graph it. So if you don't have the graph, what you have to do is pay attention to which range the x value falls in. So for f of 4, notice that f of 4 would be in between 3 and 6. So what we would have done to evaluate this is negative 4 times 4 minus 3 plus 5. We are taking the 4 and plugging it in for x, because 4 matches up with the range of the third piece of our piecewise function. All right, next up would be f of negative 4. So negative 4, that one matches up with our first one. So to evaluate that, if we didn't have the graph, we would have had to go 2/3 times negative 4 plus 7 plus 1. And then our final one, f of 2. F of 2 is in between negative 1 and positive 3. So that one we can see the answer is just 5. That one's quick and easy to solve. All right, so just to finish this thought, if we do these two calculations in our head, if I take a look at this top one, 4 minus 3 would be 1, and then negative 4 times 1 is negative 4, and negative 4 plus 5 gives us 1. The next one, the parentheses, negative 4 plus 7 is 3. When I go 2/3 times 3, the 3's cancel out, and I get 2 plus 1, which is our 3. And then the last one, the only answer was 5. On the next problem, we'll go ahead and try to evaluate a piecewise function without actually graphing it. All right, last problem. Instead of graphing this piecewise function, we're just going to evaluate 3 points. So you're going to have to figure out which range your x value falls in, and then substitute it into that equation to solve it. So go ahead and give it a try, and then I'll go over the answers. All right, if I start with f of 9, 9 would be greater than 3. So that means that I would be plugging in 9 into this bottom equation, 1/2 times 9 minus 1 plus 7. So that would be half of 8, so that's 4, plus 7. F of 9 is equal to 11. Next up, we have f of negative 3, and negative 3 is in between negative 5 and negative 2. So let's plug it into that one. All right, so it's all plugged in. So inside the parentheses, negative 3 plus 5, that would be 2. And then there's a negative sign on the outside. So that's actually negative 2 plus 4. So f of negative 3 is positive 2. And the last one, negative 2. So this one you got to be a little more careful about because there are two negative 2's here. But notice that this one would have to be part of the middle solution because that's or equal to, whereas up here is just less than. So negative 2 would be part of this function, and there's no calculation to do. That function always equals negative 6. And that'll go ahead and conclude our video on piecewise functions.